All right, welcome everybody. Today we are going to talk about lesson number 29, and this is about applications of the concepts that we saw in section 2.7. Let me preface the lesson with a couple of things. So first of all, this minute computer here does not have the graphing calculator software on it. So I'm going to be showing this lesson in class, and I will pause it and show you the graphing calculator part. But if you are for some reason watching it on your own, that part is not going to be part of the recording. So you are going to have to make sure that you can do that part on your own or go back and watch the video of the class. Secondly, technically, these are all problems with inequalities, which you could solve using the sign analysis method that we've been doing. But the fact that they are word problems and the fact that the numbers are so large and messy is why you're going to see it's a much better idea to use the graphing calculator. So take a look here at number 1. The marketing department of a calculator manufacturer has determined that the demand for a new model of a calculator is P equals 100 minus 0.00001x, and they're saying that x is between 0 and 10 million. So that means that P is the price per calculator in dollars, and x is the number of calculators sold. Basically, based on this model, they're saying that nobody is willing to pay more than $100 for the calculator, which seems reasonable. And they're also saying that they don't anticipate selling more than 10 million calculators, which is probably also reasonable. Something that I want to point out, especially something that comes up a lot in terms of calculus, is making sure you understand what all these different equations have to do with. So this is called the demand equation, but I also want you to understand that this is really telling you the price. That's kind of why it's P equals. So make sure that you know that the demand and the price, those are really synonymous. So then they're telling you about something called the revenue equation. So the revenue for selling X calculators is R equals X times P, where X is, again, the number of calculators being sold, and P is the price. So again, just to make sure you understand, X is the number of calculators sold, and then P comes from the previous equation, and that's the price. So when you get to calculus especially, you're going to have a lot of problems that talk about revenue and price and demand and cost and profit. So you have to make sure you understand how those things go together. So once you have figured out how you're going to price your calculators, once you have figured out the revenue that you're going to make, what you also want to consider is the total cost that it's going to cost you. So the cost of producing X calculators is $10 per calculator plus a $2.5 million flat fee that you have to pay, which means your cost equation, which is C equals, is going to be 10X plus 2.5 million. So more often than not, you'll be given some or all of these equations, but you do have to make sure that you understand not only what letters are being used for them, but also what they mean. So again, the price is the price at which you're going to sell the calculator. The revenue equation is how much money the company is expecting to take in when they sell their calculators for a certain price. And then the cost equation is how much it costs the calculator to actually develop and sell. The ultimate question that I want to know here is what price should the company charge per calculator to obtain a profit of at least $190 million? So a couple of really important things that we want to point out here. The first of which is they're asking you about profit. For all the equations that we have in this problem, we don't yet have a profit equation. So we are going to have to create a profit equation. And hopefully you remember from earlier in the year or just at some point in your math career, a profit is always equal to the revenue minus the cost. Remember, the profit is how much your company makes in after they pay off all their debts. So that would be the revenue, which is the total amount that they take in, minus whatever the cost of production was. And again, if you're looking to abbreviate, profit is usually capital P, revenue is capital R, and cost is capital C. Second thing is you are trying to find at least $190 million. So at least $190 million means greater than or equal to $190 million. So that fact that it's at least, that's what turns this into an inequality, which is why it's even in this section. So we're going to go ahead and take everything we have so far, and we're going to go ahead now and create that profit equation. So in order to create the profit equation, I'm going to start with the revenue equation. So notice that the revenue equation is this equation here, but I'm going to want to go ahead and distribute that X. So I'm going to get 100X minus 0.00001x squared, and be very careful that you have the correct number of zeros. Then you have to subtract the cost. And when you subtract the cost, you have to make sure that you're essentially distributing the negative. So you're going to subtract this entire cost equation, which means you're going to wind up with a negative 10x and then a negative 2.5 million. Have to make sure you distribute that negative. So now I'm going to go ahead and I'm going to combine like terms and I'm going to put it in standard form. So my price equation is equal to negative 0.12341x squared. If I combine my x's, there's 90 of them, and then 2.5 million. Anytime you're in the millions, that's kind of a clue to you that you maybe are going to be using the graphing calculator, or else you're going to wind up with just some really, really messy numbers. So I have my profit equation, but now I need to combine that with the fact that I am trying to find the price at which I can obtain a profit that's at least $190 million. So essentially, I'm going to take this profit equation, so negative and then 4 zeros, 1x squared plus 90x minus 2.5 million. And I want that to be greater than or equal to 190 million. So this is essentially what the crux of this problem is. This is the inequality that I am trying to solve. So give everybody a second just to make sure that you are writing that down accurately, making sure you have the correct number of zeros and you have the negatives and the x's where they should go, because if you are going to use the graphing calculator, you do have to make sure that you're putting everything in exactly correctly. So here's the thing. We have been doing all these problems in relation to zero. And the truth is you can do that if you want. You can subtract the 190 million and then have it in relation to zero. And then you can go ahead and find those x-intercepts. The second way that you can do this is by kind of using intersections. So I'm going to show you the intersection method just because the numbers are a little bit cleaner. But again, please make sure you're aware that the second option would be to subtract this 190 million away, have it in relation to zero, and then look for the x-intercepts. But again, I'm going to show you a slightly different way. So here is where in class, I'm going to go ahead and go over to the graphing calculator and show you how to type it into your y equals and how to make sure that you go ahead and find the points of intersection. So again, in class, this will be where we pause and go do all that. So then once we're back from looking at what in your graphing calculator, you're essentially going to have a graph that looks something like this. It's obviously an upside down quadratic for all the millions and stuff that are there. It essentially is just an upside down quadratic. So again, you were trying to find at least 190 million. So you essentially made a second y equals that was 190 million. You then went ahead and found the points of intersection. Those are going to tell you the values of x, for which it's exactly 190 million. And then because you want to have at least 190 million, that's why you would choose everything between those two x's. And again, we should have done this together, but you should have gotten that the first x value would have been 3.5 million. And the second x value would have been 5.5 million. And so anything between those two values is actually what we're looking for. So we would say that x has to be less than or equal to 5.5 million, and it has to be greater than or equal to 3.5 million. And you can write out the zeros if you prefer. I'm just going to go ahead and abbreviate. Here's the thing, though. This is not actually what the question asked. So the question actually asked, if we go back, what price... Sorry, I know there's a lot going on here. What price should the company charge? So if you're talking about what price should the company charge, you have to then take those X's, because remember, those are the numbers of calculators that are being sold, and you have to actually put them back into the price equation to actually calculate the price. You have to go back to your price equation, which is the small p equals 100 minus 0.0001x. So you're going to start by plugging in the lower bound, which would be 3.5 million. And I would actually plug it in with the zeros, or you can just make sure that you interpret it. So 100 minus 0.00001 times 3.5 million. Just double checking on my calculator here. And if you do that, you should go ahead and get $65. If you go ahead and plug in the second bound, which is 5.5 million, you're going to get 100 minus 0.001 times 5.5. And if you type that in correctly, you're going to get $45. So the ultimate answer to this question, for all that work, if the question ultimately said, what price should the company charge per calculator to obtain a profit of at least $190 million, you should charge between, so P for price has to be less than or equal to $65 and greater than or equal to $45. So a ton going on here. And this also happened to wind up being a nice value, 45 and 65. That won't always be the case. So these problems certainly take a little bit of time. You're only going to have a handful of them on tonight's homework, and then maybe one or two during the group activity that's upcoming. So certainly it takes a lot of work. You have to be extra careful. But I do think it's important to see problems like this. So let's go ahead and take a look at the second problem. Sorry, I kind of went down. And again, just to be clear, number one, that was a polynomial. So polynomial have no asymptotes. Those are the nice smooth curves. That's a little bit different here in number two. So here in number two, a rectangular page is being designed to contain 48 square inches of print. The margins at the top and bottom are 1 inch deep. The margins at each side are 1.5 inches wide. What should the dimensions of the page be so that the least amount is used? So the most important part of this least amount here, whenever you see the word least, you're going to be thinking minimum, which again is the opposite of when it says the most. That would, of course, be the maximum. So here, again, we're going to be using a graphing calculator. It's not so much an inequality, actually, but it really is solving something to do with an equation. But again, because 2.6 was right before 2.7, it certainly fits in this unit. So then from here, we're going to go ahead and set up some equations. And the truth is we have to set up two equations. So I'm going to start by finding the equation for the area of the printed region. So the area of the printed region is this here in yellow. Sorry, it's a little bit messy. So that's the shaded region. So the area of the printed region is equal to X times Y. They tell me that I can have 48 inches of square print. So I can further say that X times Y is equal to 48. And that's my first equation. So this is the area of the printed region. And now I want to write an equation for the area of the entire page. So if I want to find an equation for the area of the entire page, just like for the printed region, it's length times width, but you have to be careful. When you're going from left to right, you have to go X, and then you also have to go 1.5 inches in both directions. So the area of the page would actually be X plus 3. When it comes to going bottom to top, you have to go Y, and then you have to go an additional inch in each direction. So you have to actually go Y plus 2. Just to be clear, for these types of problems, there's two different formats. In this case, the printed region is the smaller part, and then you're adding to get the full region. The converse of that would be, what if you knew the entire region and you were trying to then talk about the printed region? You would have to subtract. So I think you have to do that in tonight's homework. So just something to keep in mind. Unfortunately, we cannot have two different equations. That doesn't help me. I need just one equation. So how do I do that? Well, I'm going to take one of the equations, preferably the easier one, and I'm going to resolve it for either X equals or Y equals. And in this case, I'm going to do Y equals. So Y equals 48 over X. I'm then going to substitute that in. Keep in mind that because this problem said, what are the dimensions of the page? That's why I know that I want this to be the equation that I'm minimizing. So the area of the page is going to be equal to X plus 3 times 48 over X plus 2. You could leave it like that, or I'm going to say x plus 3. I'm going to find a common denominator, which would be 48 plus 2x over x. And again, you could leave it like that if you wanted, or if you want to just go even one step farther, you could say x plus 3 times 48 plus 2x all over x. So certainly that should look familiar. That is in fact a rational function. There are going to be zeros, there are going to be asymptotes, and you're going to go ahead and try to now find the value for which the minimum amount of paper will be used. Excuse me. So the first thing I want to point out here is in terms of domain, okay, you would not be allowed to choose any value of x that would give you a negative or a 0. So we actually want to think about what the real world domain would be. So the fact that the denominator is just x, in order to ensure that I don't get a negative and I don't get a 0, I know that the real world domain of this problem would have to be x is greater than 0. That should feel right for a bunch of reasons. You can't have a negative page width or length. You also can't have 0. You also don't want anything that makes your denominator 0. So again, the real world domain here would be x is greater than 0. Keep in mind that if there was something other than the x there in the denominator, it would not just be x is greater than 0. It would be something else. So now from here, I'm going to have to go ahead and graph this equation. So again, if I'm showing this in class, I'm now going to pull up the graphing calculator and figure out the best way for which to graph that. After we've gone and looked at that, we're going to come back and we're going to actually analyze what we had. So after we've done the graphing calculator part, you should have something that looks like this. There's 2 branches. Obviously, anything that's to the left of the y-axis, that's going to be anything that's negative. So that's not really going to make sense. So I am looking for the minimum value here on this branch. In order to do so, I'm going to find my minimum by using my menu. And when I go ahead and do that, I'm going to get an x value of approximately 8.5. It's actually more of a decimal, but you can just go ahead and round it to 8.5. Then after you have found that, just make sure you actually answer the question. So the question was, what are the dimensions of the page? So the dimensions of the page mean I want to take my equation up here, and I want to go ahead and I want to plug in my length and my width, not divided by x, but just the length and the width. So if I do x plus 3, that's going to be 8.5 plus 3, so that's going to be 11.5. Then if I do 48 plus 2x, that is going to be sorry, that was after I found the common denominator. So I would have to divide by x as well. So actually, instead of plugging it in here, I should actually be plugging it into this one. So the first one is still good. For the second one, I have to do 48 divided by 8.5 plus 2. So 48 divided by 8.5 plus 2, that's going to give me 7.6. So that is ultimately the dimensions of my page, 11.5 inches by 7.6 inches. So again, this here is an application of a rational function, not technically an inequality in this case, but because we're in the graphing calculator mindset and just in the rational function mindset, I do think that it makes sense to have it here in this unit. So that's the end of the lesson, just showing you those real world applications. There's only a couple of these tonight, and I would imagine that they should hopefully go much faster. I did do the harder ones with you and then save the easier ones for later. So thanks very much for tuning in, guys, and we will catch you next time.